This photo was taken at the Museum of the American Indian of Khipu, artifact number 17-8826. This is the first Khipu that was featured in the article Numbers and Relations from Ancient Andean Quipus by Marcia, Ascher, and Robert Ascher. There's a link in the description below. They refer to it as AS1, AS for Ascher. The first thing we notice about this Khipu is that it's mostly shades of brown, and that there are two main clusters on kind of a lengthy primary cord. So let's take a look at a diagram so we can kind of separate out the cords and the knots a little better. In this diagram, the Y is drawn to scale, the X is separated out so we can see the cords, they're not bunched together like they are in the original photo. And this will help us to better see the knots and their placement on the cords, and also see the individual cords. So we can see that there is a long stretch of cord on the left, also on the right. Primary cord is quite long. It's drawn shorter here to fit well in the diagram. These cords are grouped by pendants. The pendant cords are attached to a top cord, so they're grouped by the top cords and also by spacing. The primary cord and the pendants are all the same shade of this medium brown, except for when the primary cord changes color. Looks like it's mottled with a light brown and a dark brown, but it changes color after the pendant cords. I don't see a particular pattern in the subsidiary cords. There's a different number of light brown, dark brown. There's only one that has this second cord level, so subsidiary on a subsidiary. If you see any patterns in the subsidiary cords, please feel free to leave a comment. These ones that are gray, these were noted as being undyed. So let's get a closer look here at the knots. So it does look like the cords with more knots are shorter, which could indicate that maybe they started out roughly the same length, and then as each twist of the cord is made to create the knot, the length is used up. With the exception of this one here, number 6, is quite long. And here's the first top cord and its subsidiary. Moving on to the second top cord, I can see that the top cord is significantly shorter, but it has a raveled end. It wasn't noted as having a broken end, but where it is about the third of the length of the first top cord, and the first top cord has the subsidiary quite a ways after the knots. Maybe this one was broken, and maybe it should have had a subsidiary, or maybe it was intentionally like that. It has a lot of these single knots, so it's quite possible that the knot is shorter just because, sorry, the cord is shorter just because of the knots. And here it's resulting 6 pendants and their subsidiary cords. One of them changes color partway through the cord. And they seem pretty consistently 2 subsidiaries on each of these 4 cords in the center. So each group has 6 pendant cords that are looped into a top cord, and each group also has 8 subsidiary cords. This is a more simplified diagram to kind of tease out the number values that are in the knots. These numbers Above the primary chord are the name of the chords. So we have chords 1, 2, 3, 4, 5, 6, and then down here chords 7, 8, 9, 10, 11, and 12. The top chords are T1 and T2, and all the other numbers are values. So the chord value of the knots in that top chord are 101. If we look at the sum of the pendant chords, we can see that the first group matches exactly the top chord, and this is a sum of just the pendant chords, not the subsidiaries. The bottom is 10 different. This difference of 10 between the 83 and the 93, it could be that the top chord is saying, like, this is the amount that was owed by the village, and the pendant chords are saying this is the amount that was given, and there is a discrepancy. This could be an error in data entry, either on the part of the chord keeper or the person who is taking notes on the observation. They're not always exact. The quipus do have, it's difficult to say if they're mathematical errors or if they're intentional, but this difference is a difference of 10. This is one single knot. So, for example, in chord number 8, if it had 3 single knots instead of 2 single knots, it would have a value of 30, and these would match exactly. And that would bring us a little closer to, this one is 30 or 39 and 40, and the bottom one's 20 and 38. These, the second and fourth chords are quite similar and on the first group, and they're a little more different on the second group. Also, the first chord of each group has a value of 4. The subsidiaries look more regular in the second group. Each pendant chord, there are 4 pendant chords with 2 subsidiaries each, and the first group, they're kind of scattered, and this is the one that also, this chord here is the one that had a subsidiary on top of a subsidiary. So this first chord, both of them have a value of 4, and it looks like on both groups, the second and fourth pendants in the group are quite high, and the other 4 chords are considerably lower. They both have a subsidiary that has a value of 20, and all the other ones are like less than 10. But this one is a subsidiary on a subsidiary. 22 is the sum of those two. So let's check back at our more detailed image real quick. Pendant number 4 is here. So it looks like the values are 17 and 5. So that is quite different from 20. Going back to the simplified diagram, checking the notes of what Ascher wrote in the article that there's a link to below. She says that the sum of the medium brown and the light brown subsidiaries each equals 31. In the first group, the top chord plus subsidiary equals the sum of the 6 chords and 8 subsidiaries minus 31. In the second group, the top chord equals the sum of the 6 chords and the 8 subsidiaries minus 31. So I can let you double check the math at home. And that's it for Ms. Khipu.